Welcome to the last unit of Algebra 1. You've finally gotten to Unit 13, and in this unit we're going to talk about square roots and the quadratic formula. So the first lesson in Unit 13 is about operations concerning square roots. So your aim today is a couple things. One, the most important one is that you can reduce radicals into their simplest form by using factoring and perfect squares. So at the end of this lesson, you really want to feel comfortable reducing radicals. But the first few exercises are going to be kind of review from operations with radicals that you've done in 8th grade. So let's read. Square roots, cube roots, and higher level roots are important mathematical tools because they are inverse operations to the operations of squaring and cubing. So inverse operations means the opposite. So what they're saying here is, look, if I have a positive 3, what's the inverse of positive 3? It'd be negative 3. So if I have x squared, the inverse of x squared is the square root of x. So when we talk about inverse, that's the kind of thing that we're talking about. We're talking about the opposite operations. So the opposite operations of squaring is taking a square root. So exercise 1 says, find the value of each of the following principal square roots. So these are all called perfect squares, and we've talked about this before. Okay, principal square roots are perfect squares. So exercise 1, find the value and write a reason for your answer in terms of multiplication. So this first one, the square root of 25, the square root of 25 is going to be 5 because, and here's my reasoning, because 5 times 5 is 5 squared, which gives me 25. So the square root of 25 is 5. Letter B, the square root of 9 is 3, because 3 times 3 equals 3 squared, which gives me 9, right? And the inverse of the squared is the square root. Okay? Same thing for square root of 100. The square root of 100 is 10 because 10 times 10 is 10 squared, and that gives me 100. So let's get to a little bit more trickier square roots. The square root of 0, actually it's not too terribly tricky, is 0 because 0 times 0 is 0 squared, which gives me 0. Same thing for 1. The square root of 1 is also 1. But as we get into things with like fractions, it gets a little bit trickier, but the property still applies. So what we're going to do is we've got the square root of 1/4. The square root of 1/4 is actually 1/2, and I'm going to tell you why. Because 1/2 times 1/2 is 1/4. What's 1 times 1? 1. 2 times 2 is 4. It's multiplying fractions, so we get, 1/4. You could also say that, it's 1/2 squared. Another interesting way to think about this, and I prefer this way to think about it as well, is if I have, and let's rewrite this here. Let's say I have the square root of 1/4. It's the same thing as saying the square root of 1 over the square root of 4, which give me 1/2. So either way you think about a square root with fractions, either way works. Okay? So for this one, we can say this is the same thing as the square root of 64 over the square root of 9, which would give me 8/3. Oh, sorry, not 8. My bad. Yes, 8. 8/3. Or you can think of it in terms of, because 8 times 3 over 3 over, 8/3 times 8/3 gives you 64/9. So either way you think about a radical with a fraction works. Okay, so this is kind of a little bit of a review. Now, coming into exercise 2, we need to think about something else that's important when it comes to square roots. It's generally agreed upon that all positive real numbers have 2 square roots, a positive one and a negative square root. And we designate that by either including a negative sign or leaving it off. So when we come to this exercise, when it says give all the square roots for each of the following numbers, give all of them, it wants the positive and the negative square root. So when I write the square root of 4, I can say the square root of 4 is going to be 2 or negative 2. because remember, 2 squared gives me 4. Sorry, that 4 turned out to look like a 9. 2 squared gives me 4. And if I can rewrite this in a better way, let me try to rewrite this a little bit better. Okay, I can have 2 times 2 to give me 4, or negative 2 times negative 2 also gives me 4. So 2 or negative 2 are both square roots of 4. And you'll also see this sometimes with this notation as plus or minus 2. Okay? So 36, the square root of 36 is going to be 6 or negative 6, or you could say plus or minus 6. And the square root of 1 over 16. Again, I like to do this where I put the square roots on both and get 1 over 4. So my square roots are 1/4 or negative 1/4, or you can say plus or minus 1 over 4. Okay, this plus or minus symbol right here, when you see this plus or minus, like if I say plus or minus 6, that means it is positive 6 and negative 6 as solutions. Okay, that's what this notation means. And you'll see it a lot. So plus or minus and square roots always have a positive and a negative solution every time. Okay? Exercise 3 and 4. Given the function f of x equals the square root of x plus 3, which of the following is the value of f of 46? So remember, this notation wants us to plug in 46 for x. So I'm going to rewrite, instead of f of x, I want f of 46 equals the square root. Now instead of x, I'm going to put in 46 plus 3. And now I'm going to simplify. I'm going to leave my square root symbol, and 46 plus 3 is 49, and the square root of 49 is going to be plus or minus 7. Now I don't say that can't be 22, can't be 5, can't be 16, so the answer has to be 7. If the answer here was also negative 7, that would be correct as well. Plus or minus 7 is the correct answer here. Okay, so this answer fits our answer choice. Exercise 4. Square roots have an interesting property when it comes to multiplication. So let's just talk about this idea of multiplying roots. So let's look at A, B, C, and D. So A says the square root of 4 times the square root of 9. Well, let's first, what is the square root of 4? 2. What's the square root of 9? 3. Okay, so 2 times 3 would give me a 6. Okay, we're going to ignore the negative values right now, because we know most of the time when you work with square roots, you only think about the positive. So we're only going to work with positive square roots for this exercise. You could have negative square roots, but we're just going to worry about the positive. Okay, now B, when I simplify, 9 times 4, now do that first, and I get the square root of 36. I still end up getting an answer of what? 6 for both A and for B, which is kind of interesting. There's something going on here. Let's see if the pattern holds true. The 4 and the 25 here are separated, so I'll do them individually. The square root of 4 is 2, and the square root of 25 is 5, so I get an answer of 10. Now that the 4 and 25 are underneath, I'll do that first to get 100, and I still get that answer of 10. So this leads us to an interesting property of multiplication of square roots. It leads us to thinking about this. When you notice in the last exercise is the following. The first one says the square root of A times the square root of B equals the square root of A times B. So you can put them in the radical together. And likewise, for the second one, if you have A times B inside the radical, you can split them up into 2 separate radicals. Now this property is really important because of this next sentence. One obvious use for this is to multiply 2 very unfriendly square roots to get a nice result. So if we look at question A, can we take the square root of 2? Does it have an actual value? No. Can we take the square root of 8? No. That's what it means by unfriendly. Unfriendly means you do not get a whole number. And we're going to encounter these a lot. And the Regents does not like you to have decimals for answers, so we have to kind of leave it in this radical form. So what we can do here is I can remember my property of radicals, and I remember, hey, if I have two radicals that don't really look good together, or I can't find the integer, I can do this and put them inside under one radical symbol. And what this is going to do is I'm going to have now 2 times 8 to give me 16. And is the square root of 16 something that we know how to find? Absolutely. The square root of 16 equals 4. So we just took something difficult to find, and we found out that this crazy thing right here actually equals the number 4. Okay? You could put plus or minus 4 here. It doesn't really matter, right, for this exercise. We're going to keep working with positive solutions, but plus or minus 4 would be the best answer. Let's try letter B. Now, 2 unfriendly, not perfect squares, but we can put them together underneath as 12 times 3, and now I'm going to get the square root of 36, which comes out to be a number I know how to take the square root of for a plus or minus 6. So this property really helps us. It only works with multiplication. This does not work with addition. If you have something like the square root of 2 plus the square root of 8, you do not do this. This does not work. Do not do this. Okay? It only works for multiplication. So be really careful here. You cannot do this. This is bad. Only works for multiplication. So the last one, make 1 square root, multiply both of your unfriendlies. 20 times 5 would give me 100, and the square root of 100 works out to a nice plus or minus 10. Okay. So exercise 6, this leads us into talking about something really, really important, and that is to simplifying square roots. So this is a really antique, very old skill, and it only ever really comes up on the Regents. So I need you guys to pay really close attention to the next about 10 minutes of this lesson, because this is the core idea of the lesson. So we're going to talk about something called simplifying square roots. Okay? So I'm going to kind of ease you guys into this. All right? So letter A says, list out the first 10 perfect squares. We've done this a lot. The first perfect square is 1. The next perfect square is 4, then 9, then 16, 25, 36, 49, 64, 81, and 100. Now, if you're confused as to where I got those numbers, remember from, a long time ago, 1 times 1 is 1. We talked about this before. I'm just getting all of these perfect squares, right? So this is 5 times 5. Another way to think about this, actually, and I think I'd rather explain it this way than what I'm doing right now, is for all of these numbers we have, if I take the square root of them, I will get a whole number. If I take the square root of 4, I get 2. If I take the square root of 9, I get 3. If I take the square root of 16, I get 4, and so forth. All of these come out to whole numbers. They are whole numbers when you take the square root. Now, on a standardized test, let's say that we have this one right here, letter B. Consider the square root of 18, okay? So the square root of 18, if we take that square root of 18, I'm going to my calculator, and I put this into my calculator. If I put square root, control square root 18 in my calculator, hit enter, amazingly enough, these calculators will do radical form only when it's not in test mode. When these calculators are in test mode, this will pop up, and instead you will get a decimal for this. So convert to a decimal, hit enter. The calculator will show this right here, this 4.24264. The Regents will not want the decimal. They don't want the decimal of square root of 18. They wanted it in radical form. So that's what we're going to teach you how to do, is how to get it into simplest radical form. So the first step we have to think about is I have the square root of 18, and now I have to think about this part. which one of these perfect squares that we've listed is a factor of 18. So I'm going to look at my list. I'm going to erase this to maybe help you guys out a little bit. Look at this list. Do any of these numbers divide into 18? And when I look at this list, I see this number right here. Does 9 go into 18? Yes, because 9 times 2 is 18. So yes, 9 goes into 18 2 times. Okay? Once I know that information, now I can start to simplify this. So pay very close attention. I have the square root of 18. I'm going to rewrite this using my property I just learned. As I'm going to break it up into this right here. I'm going to break apart the 18 into 2 separate square roots. It's the same thing I really did here, except backwards. Right here, they were already separated, and I combined them. Now, I'm starting off with a whole number, and now I'm separating them. Now what this does is square root of 9, that converts into a whole number of 3, and the square root of 2, I just put right next to it, and that is my reduced form. Okay, this is called reducing a radical. All right? Really, really important skill here, and we're going to practice it in exercise 7. Okay? So, the key to simplifying any square root is to find the largest perfect square that is a factor of the radicand, what's underneath it. If you pick not the largest, you have to keep simplifying until you get to the smallest. Okay, so I'm going to go ahead and write those out again up here. So we have them 1, 4, 9, 25, 36, 49, 64, 81, and 100, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so, oh, I skipped, what, did I skip one? Yeah, I skipped 16, sorry. I skipped 16. So 1, 4, 9, and 16. So it's always helpful, in fact, if I were you and I, got to the regents, what am I doing here? I would write these down on my paper somewhere. When I sat down, I'd be like, okay, what are all my perfect squares? And I'd write them down. Okay, so here they all are, 1, 4, 9, etc. So let's reduce some of these radicals. So the first one is the square root of 8. Now think, how can you break up 8 into a perfect square? Does 1 go, never consider 1. 1 is not really part of it. Start with 4. Does 4 go into 8? Yeah, but is there one bigger? Does 9 go into 8? Nope. So 4 is my biggest one. So I know that the square root of 8 is really the square root of 4 times the square root of 2. And now I can convert this square root of 4 into just a 2, because the square root of 4 is 2, and then just bring that square root of 2 down as my final answer. Okay, that's a pretty simple one. Let's move on to the next one. 45. Okay, let's first of all, does 4 go into 45? No. Does 9? Yep, 9 goes into 45. Does 16? No. 25? No. 36. So I'm going to stick with this at number 9. So I know that 45 is the square root of 9 times the square root of 5. Now, what does the square root of 9 turn into? The square root of 9 turns into a 3. Square root of 5 can't be simplified anymore, so there's my reduction for my square root. Okay? All right, letter C. Is there any factors of 48 that are perfect squares? 4 is a factor of 48. I could do square root of 4 times the square root of 12. But I'm not going to do that, because if I keep looking, I'm going to notice that 16 is actually also part of a factor of 48. So I'm going to instead do the square root of 16 times the square root of 3. Now, it might be helpful to use a calculator to find factors. If you're not great with your multiplication tables and you don't know that 16 times 3 is 48 off the top of your head, you might have to keep attempting to multiply in your calculator until you find that high radical. Okay? So the square root of 16 converts into a 4, and the square root of 3 just gets brought down next to it. Okay? Now D has something interesting going on. D has this negative. We're not going to worry about the negative until the very end, right? We can just keep carrying it through. We're going to have the square root of something times the square root of something. We're just going to leave the negative in front. And when I see something like 75, I instantly think the number 25, right? I always think quarters. There are, 3 quarters and 75 cents, so I know that 25 times 3 is 75. When I simplify this, the square root of 25 becomes a 5. I carry down my negative and bring over the square root of 3. Okay? 72. 72 is a little bit trickier. Again, like I said, 4 is a factor of 72, but if you keep going, you will find that 36 is also a factor of 72. So I have 36 times square root of 2. Okay? 36, the square root of 36 is 6, and the square root of 2 gets brought down. Now let's say for an oh no situation. Let's say for the square root of 72, you made a mistake, right? And you said that 72 is actually the square root of 2 times the square root of 36, because you did the 2 first. You're going to notice that this 36 will still simplify to a 6, even if you did the 2 first. So all you have to do is make sure that you put the 6 in front when you reorder it. Okay? And finally for F, okay, I'm going to show you two ways to do F. When I first see 500, I think 100 as a perfect square. So I think negative 100 times the square root of 5. This would simplify to a negative 10. Oh, sorry, not with the square root symbol though, just the negative 10. Times the square root of 5, which would give me a final answer of this. Now let's say you're nervous and you're taking the regents. And let's say that you think the square root of negative 500 is the square root of 25 times the square root of 20. Because that is true, right? If I go to my calculator and I do 25 times 20, I get 500. So let's say that I think that, okay, 25 is my perfect square. All right, let's work with that. So I'm going to have the square root of 5, which changes into a 5, times the square root of 20. But there's a problem here, because the square root of 20 has a perfect square in it. It's got the perfect square of 4 times the square root of 5. I can break up that 20 into 4 and 5. So now I have a second layer of radicals, but this square root of 4 changes into a 2, and I still have my square root of 5, so I still end up getting my answer of 10 square root of 5, both ways. Remember, it's a negative though. I still get the 10 square root of 5, I just had to do my reduction twice. So sometimes that'll happen if you don't see the biggest perfect square right away. Okay? Please work on your fluency, because some of the fluency problems are some addition problems of review from 8th grade that I don't teach in this video. So you might want to check those out, and they will be on the mastery. Maybe ask for help if you don't remember. Okay? Good luck.